We found a 100K resistor in the parts box. It's a brown, black, yellow, and the gold is the tolerance band. And I want to change the resistor that's connected up to the scope right there. And I could use the test probe to actually yank the resistor out. It's not a lot of force. And then I could connect it back to the probe and use the probe as a little pair of pliers almost. And this is the feedback resistor that we're changing. And when I do that, you could see there's some craziness over here as I was doing it, and as I was plugging it in, the voltage is flying all over the place because the op amp basically had a gain of infinity in theory, but now it's back settled down again. So we'll take some breaths, see how things are doing. And I just took a series of breaths. So the signal is very noisy. If you look at this green band here, there's a ton of noise. It's higher frequency noise, so it just kind of looks like a block. It's probably 60 hertz. We could zoom in on it by changing the time base in a minute. But just looking at the amplitude of the waveform that's kind of superimposed on the noise, because the noise is adding into the signal of the breath rate, you can see when I do an exhale, right, we're getting about 200 millivolts of signal, which isn't bad. We're on 500 millivolts. We're moving, about a third or more of a division. So we're getting a decent signal. There's just a ton of noise on there. So we could look at the noise real quick. And the noise is really independent of breathing or not. And we know the noise is high frequency just because it's just like a blur. So we change to a faster. Now we're on 50 milliseconds, and you can see there's some ugly looking noise on there. And see, it's telling me I'm at my limits, and that's because I'm on the roll setting. If I go to the horizontal menu, go back to normal oscilloscope mode, and let's see, what are we triggering on here? We need to go to, let's force the trigger. We need to go on automatic trigger. And no idea why we're seeing half the screen. There it is, okay. So I hit stop. That waveform's a little hard to see. And let's see, what is it right there? So 5 milliseconds per division. And we know that 60 hertz is 16.8 milliseconds. So if we count 5, 10, 15 and change, so you could see there's a 60 hertz wave in there. It's really messy though, and it's really messy just because of the way the wires are acting as antennas. So we're getting noise from different stages, and it's mixing together in this really odd way and making this awful looking waveform that we see right here. So the good thing about that though is we could probably remove that with a low pass filter. Now a low pass filter is something we're not going to get into in this lab just because it's enough that you learn the AC low or the AC high pass filter, or the DC blocking filter we can call it. But we will investigate that before the end of the semester. So for now though, we could say that things look like they're kind of a success.